finish up now with substitution, integration by substitution, by just looking at a couple of a little bit more demanding type examples. Let's have a look at this one. So we've got the integral of 1 over 1 plus 9x squared dx. Now it's important to make the right substitution. On first inspection you could say, oh, maybe let u equals 1 plus 9x squared. But if you did that substitution, you'll find that the x's wouldn't cancel out. You'd have u's and x's involved, just like the last example I did previous video. And so you'd be stuck. What examples in the table of integrals that you've learnt look a little bit like this? Well, you know that if it's 1 over 1 plus x squared, that will be arctan. So we'll make this as u squared, and so that might help us. So what we're going to try and do is go 1 over 1 plus u squared. So we've got u squared equals 9x squared. So that will be our substitution. In other words, we're going to let u equals 3x, and that way u squared will be 9x squared, and that will get me an easier integration to do. So that's our substitution. Our next step is to find u dx is equal to 3. And we make dx the subject, so we just switch these two around. So we get du over 3 equals dx. There are no upper and lower bounds, so we're going to have an indefinite integral, so we're going to have a plus c. So our next step is that the integral of 1 over 1 plus 9x squared dx, when we do the substitution, is the integral of 1 over, now 9x squared is equal to u squared, so it'll be 1 plus u squared, and dx is equal to du over 3. So that 3 can come out the front, so it'll be 1/3 the integral 1 over 1 plus u squared du. And that'll be 1/3. Now the integral of 1 over 1 plus u squared du is arc tan of u. Another way to write arc tan is tan to the minus 1. That's what you'll see on your calculator, but arc tan is the same thing. It is the angle whose tan is. And then, because we've got the integral with no upper and lower limits, we've got to put plus c. So that'll be 1/3 arc tan, back substitution. This did not have any u's. The original question did not have any u's in it. We've got to substitute for u. U would be equal to 3x, so it'll be arc tan of 3x. And we'll put that in brackets to show that it's the arc tan of all of that, plus our constant of integration. So that's that one. The second one. Okay, we know the integral of e to the x is e to the x, so probably we're going to let u equals minus x squared, and that might help make this a little bit easier. So my substitution is let u equals minus x squared. Then we'll get the integral of e to the u, and that's an easy one. The integral of e to the u is e to the u from our table. So if we've got u equals that, then we find du dx, and that's equal to minus 2x. And we want dx, we're going to do a substitution up here for dx, so we're going to make this the subject, so we switch those two. So we get du over negative 2x is equal to dx. So that'll allow me to do a substitution for that. So our original question was, so we better just do a little bit of a dotted line down here so we don't get... So our integral of x e to minus x squared dx will be the integral. Now we'll leave that x as it is. This minus x squared will be just u, so that'll be e to the u. And then instead of that dx, we're going to write du over minus 2x. Alright, now we said that if we've got an x involved here, leave it as it is, but it should cancel out with what we've done when we've done the substitution for dx, which it will. So that x will go once. The negative 2 down there, it's 1 over negative 2, so that will come out the front. 1 times e to the u is e to the u du. The integral of e to the u will be just equal to e to the u plus c, our constant of integration. Once again, we have introduced the u. The u wasn't in the original question, so we've got to go negative a half, do the back substitution. What was u equal to? Negative x squared. That's our constant of integration. So the template works in most of the cases. If it doesn't, there are other techniques, but that will be covered in later courses. So for the time being though, make the right substitution and you'll be and follow the template and you should be able to work out these integrations.